Today I'm going to be going over the flashing LEDs project that I made for DC circuits. My name is Jacob Holyfield. Just a quick presentation outline. The project description, we'll go over what the project is. The parts list, schematic, we'll go over how the circuit works. Some pictures before and after assembly. Build and debug challenges that I encountered while making it, and some troubleshooting techniques that I used. And then we'll go into some conclusions. First, the project description. The function is to turn on an LED and have the other one off, and then swap which one's on and off every few seconds, kind of like a train light. Some features that you're able to change the time each light is on and off. It's not a super complex circuit, but it's medium complexity. I didn't have too many challenges while while making the project, other than soldering the parts correctly for the PCB version. Just a quick parts list. We need 2 LEDs, 2 trim pots, 250 kilo ohms is what I used for the PCB version. The breadboard version I used different, less resistive trim pots, and that makes it faster. I'll go into that in a little bit more detail later here. We need 2 transistors, 2 capacitors, 2 1 kilo ohm resistors, and 2 10 kilo ohm resistors. And then either a breadboard or a PCB to mount all the parts to, as well as a 9-volt battery. And if we're doing the PCB version, we need solder to make everything stick together. So this is the schematic for the project. Basically, we have our 9-volt battery here, and that feeds circuit into the LEDs. And then the LEDs don't turn on until the capacitor has been charged, allowing this circuit or this transistor to close, making a complete circuit here. So basically, in order to charge this capacitor, we need the resistor here allows it to charge, and so more resistance here makes it longer for it to charge. Less resistance here, it charges quicker. Once it charges, then it's able to close the transistor and thus turning on the LED on that side because it closes the circuit. And then once the capacitor runs out of charge, it stops, and by the time when it runs out of charge, this one takes over, and we'll open this one, and so you get a LED 1 turning on, and this one's off, and then LED 2 turns on, and this one goes off. Some before assembly pictures. So this is for the soldered version. We got our 2 LEDs here, as well as capacitors, transistors, and the trim pots there, as well as the PCB and some solder and resistors. And then the breadboard version is pretty much the same, except we have a breadboard, and I use different trim pots for the breadboard version. Here's a assembled breadboard. Basically, this picture doesn't have the battery connected in, but I have it set up so that it's the positive lead of the battery there, negative lead there. Yeah. Here's a video of the breadboard version working. And as you can tell, it's pretty fast because I used a 10K and a 1K variable resistor, because that's all I had on hand at the time. Here is the PCB pictures after assembly. Here we used different trim pots or variable resistors. The PCB version was a little bit easier to assemble because it's sort of all laid out for you. Yeah. So here's a video of the PCB one working. As you can tell, it's a little bit slower because I'm using the correct resistance trim pots there. Some build and debug challenges. For the build process, the soldered version, you just put the parts where they're supposed to go on the board, and then solder. For the breadboard version, you need to look at the schematic to ensure you have the correct connections and are laying everything out correctly. As far as debugging goes, if something isn't working, you need to follow the flow of electrons to figure out where the issue is. Usually it's just that you connected something to the wrong spot or whatever. On the solder version, you also need to make sure that you didn't solder any connections together that aren't supposed to be soldered together. And some lessons that I learned. I successfully built both the PCB and the breadboard version. I improved my soldering skills, and I learned how a capacitor can be used in a circuit. Thank you for watching, and have a good day.